Okay, now let me officially welcome everybody back to ERP Suite's Find Your Cloud webinar series. This week, as you know, we're talking all things Microsoft Azure. And I'm honored to introduce you once again to Frank Jordan, our Director of Technology at JD Edwards Focus, and Paul Scheer, our Executive Director of Cloud. And this week, they're joined by our Senior Cloud Engineer, Dan Coyne. Again, just for the benefit of people who may be new to ERP Suites, or maybe even just newer to our cloud services, our Find Your Cloud webinar presenters are part of ERP Suite's Cloud Advisory Services practice, and collectively they help customers leverage the cloud to accomplish their digital transformation goals. So you can see here the types of things that fall into that, their sphere of knowledge and practice. If you're able to join the AWS webinar last week, this agenda is going to look very familiar. We're going to start again with a broad look, this time at Azure, and drill down into the ways it delivers performance and resilience for JDE. Then we'll look through the database nuances, the licensing that you should be aware of, and the implications that it has. So, Dan, let's get started with a look at some of Azure Fast Facts.
Thanks so much, Diane. Just for some quick facts to get us started, Azure has the most regions globally compared to all the other public clouds, giving users the flexibility to run their workloads where they want. It's also the fastest growing cloud with 50% year-over-year growth last year. And the last statistic I really like is that 95% of Fortune 500 companies are using Azure, helping to really give the platform some credibility, in the competitive cloud wars.
Thanks, Dan, for that overview. So before we get into the gory details, can you tell us about some common misconceptions concerning Azure?
Yeah, sure, no problem. The first one that comes to mind is that Azure is just for Windows, but the truth is that Linux is actually the fastest growing operating system on Azure.
Well, that's good. Anytime we have a choice, I like to run servers with Linux instead of Windows. It's a bit more stable and secure.
I prefer Linux as well, but that's primarily because I don't like paying that Windows tax.
Yeah, for JD Edwards servers, though, you do have two Linux choices, and that's Red Hat Enterprise and Oracle Enterprise Linux. If you're running SQL Server, you will need Windows at least for the database and enterprise servers.
I thought you could run SQL Server on Linux now.
Technically, it can, but it's not certified as a configuration from Oracle for Enterprise One. Also, those enterprise servers, they need Windows for the Microsoft ODBC drivers to connect to SQL Server as well. Bottom line, you should always check the Oracle certification page to make sure whatever you're wanting to deploy is supported.
So there's no issue with using Linux for WebLogic servers, even if your database is SQL?
No issues that I've seen. Just make sure you have the correct Microsoft JDBC driver, and it'll work fine. As a matter of fact, we've used a similar model for IBMI or the AS400 for a number of years with WebLogic servers talking to the AS400. The great part is it's your choice if you want WebLogic on Linux or Windows.
Frank mentioned Oracle Linux on the last slide. Another misconception we often hear within the JDE community is that you can't run Oracle Linux on Azure.
So this appears to be an Oracle published image on the Azure Marketplace.
Yep, sure is.
And that's a big deal, as I always like to run my WebLogic servers on Oracle Linux.
So you don't like Red Hat, Frank?
No, Red Hat's great, but it comes down to it's an extra vendor in the support mix. That gives you another throat that you have to choke if something goes wrong, at least as far as JD Edwards is concerned.
And Oracle Linux costs a lot less.
And there's that too.
Thanks, Dan. This is very interesting. So let's get into some of those gory details now. Azure is a somewhat non-obvious choice for JD Edwards. AWS makes sense as it has market share due to its first mover advantage. And OCI is also a strong contender with its home field advantage. Why in the world would anyone want to think about putting JD Edwards on Azure?
One very big reason why someone might want to deploy on Azure is that it still supports Windows Server 2008, 2008 R2, and SQL 2008 R2, and provides them with up-to-date security patches. This is the only supported option for 2008 in the public cloud, and this can really help customers with their migration.
Yes, I actually had a customer recently migrate to Azure for this very reason. So, the customer was running Enterprise 1 8.11, and they had Windows 2008 R2 and SQL Server 2008, and they were off JD Edwards maintenance or on sustaining support. Azure was a great option for those older workloads because it did ensure you could still have the security patches and the basic support. The thing to think about is, Windows 2012 or 2012 R2, that wasn't supported for JD Edwards until tools released 9.1.4. So again, anyone running Enterprise 1 on an older release of tools most likely is going to have Windows 2008 somewhere in that JDE environment.
What about customers that might still be running Windows 2003?
Well, yes, well, some of them are still out there, but I wouldn't move that to the public cloud. For older operating systems like that, our private cloud offering probably would be a much better choice.
Another big reason for customers to think about Azure is that they already own Windows and/or SQL licenses. The Azure Hybrid benefit allows you to bring those licenses to the Azure cloud, helping to protect your existing investment. And when you bring these licenses, you get a cost savings compared to the traditional VMs.
Right. We talked with Josh about this last week related to AWS. With AWS, you have to effectively orphan any existing SQL Server licensing and get that licensing through AWS embedded in the instance. It gets really, really expensive.
Yep, that's right.
It's important to note, though, that this restriction only applies to AWS. There are BYOL options for OCI and Google Public Cloud. Could you walk us through the economics for each of these clouds?
Yeah, I'd love to. Let's use an example of a server with 4 vCPU, 32 gigabytes of RAM running Windows. Let's start by leaving hybrid cloud benefit out of the picture and compare the options. At Azure, that server without hybrid benefit will cost $318 a month. Something that's pretty amusing and entertaining is that it's actually the exact same price at AWS. If we go with GCP, it's $3 more, and here's the crazy part. OCI comes in at $210. That's more than $100 less than all the others.
Wow, that's kind of surprising. What exactly is going on here, Dan?
A couple of things. The first is I'm using on-demand pricing to compare apples to apples. Oracle does not do term discounts the way the other clouds do. You are basically getting the equivalent of a 3-year reserved pricing without making any commitments. And if you compare these to the 3-year pricing on the other clouds, the delta shrinks a lot.
So you're getting a lot closer on the economics with the other clouds using term commitments, but you have to give up a lot of flexibility to get there.
Exactly. And given that the key feature of public cloud is flexibility, that should really get you thinking on where you want to deploy. One other thing to keep in mind as well is Oracle doesn't offer fractionalized or burstable VMs the way that AWS and Azure do. If you have a lot of VMs with relatively light CPU utilization, Azure will win on the economics even without the hybrid cloud benefit. But we're going to talk about those burstable VMs in a few minutes.
So speaking of the hybrid cloud option, what does that pricing look like?
On the surface, it blows everything else out of the water. It's important to remember, though, that $187 a month isn't your true price. The true price is $187 plus whatever portion of your EA or MPSA that's funding your hybrid rights on this server to begin with.
So for comparison purposes, should companies think of the EA or the MPSA as a sunk cost?
Yeah, but only for the remainder of that term. Companies should be thinking long term. What is the true TCO over the next 3 to 5 years?
So that's pretty impressive, Dan. What happens with the analysis if we throw SQL into the mix?
Let's go ahead to the next slide. Again, let's start the comparison without the hybrid benefit. A 4 by 32 gig server with Windows and SQL Standard Edition will run you about $622 a month on Azure. On Amazon, it comes in at 668. Google is a bit less at 659, and Oracle comes in at a whopping 783 a month.
Wow. Oracle just went from being the low cost to the high cost option as soon as you threw SQL in.
Yes, but remember that I previously mentioned that with SQL on OCI, you can bring your own license under the Microsoft Mobility Program. In that scenario, the price drops to $232 a month.
Wow.
Yeah, but remember to add in all these costs of those licenses to your overall number. And then Google comes in at $321 a month with bring your own license, and Azure beats them all at $187 using that hybrid cloud benefit.
Well, can I have more RAM? I really like more RAM.
Yeah, and for Azure and AWS, you can go to a larger instance type to get more memory, but constrain the CPUs so that the licensing requirements are the same. Basically, you're going to get a server with 8 vCPUs, but you're just going to turn off 4 of them. For OCI and Google, you can scale that RAM independently. So I mentioned those burstable VMs before. The Azure B-Series VM CPUs are burstable and have some economic benefits compared to general purpose compute.
Such as?
It's really best to illustrate with some actual prices. Let's say you need a 4 vCPU and 16 gigabyte RAM server. Using general purpose compute, the monthly price is around $293 a month. Optionally, if we use burstable compute with the same 4 vCPUs and 16 gigabytes of RAM, the price drops to $158 a month. Yeah, and that's around a 46% savings.
Yeah, that savings is pretty incredible. But, you know, in economics, there's this term called Tannstaffel. There ain't no such thing as a free lunch. So what's the catch here with these burstable VMs?
Yep, that's a great question. The D4A on the left can run all 4 vCPUs at 100% utilization 100% of the time for a total of 400% utilization. The burstable B4MS can use around 90% on 1 vCPU 100% of the time. So if you want to burst above that 90%, it must use some credits. And then whenever the server is under that baseline of 90%, it starts banking those credits for later. And like I mentioned earlier, when you're above that baseline, it consumes those credits with a starting balance of 120 credits.
This is a little bit confusing. Could you try to explain it to me like I'm 5 years old?
Sure. And the best way to explain is by using a working example. So if we see here, we start with a balance of 120 credits to start. In minute number 1, we ran at 56% CPU utilization. Since our baseline is 90% and we were underneath that baseline, we actually earned some credits. You could see the running total of credits on the right. So now once we go into minute number 2, we actually used 120%. This is over the baseline of 90%, so that means we've actually spent a credit, and you can see the running total there. Skipping a few minutes ahead, at minute 6, we were really running hot at 212% utilization. This causes us to burn 1.2 credits. Note that our balance, though, is still above where we started, because in minute 1, 3, 4, and 5, we were actually banking credits and only burning them in minute 2 and 6. And so you can follow that running total as we go down. Over a full 15-minute period, we banked 1.3 credits because we were under the baseline more than we were above it.
Thanks. That was really helpful. Frank, how would we use this in the context of JDE?
Well, this will work really well for some of the JDE servers where most of the time the CPU is low. Like consider using it for the deployment server or WebLogic servers or anything non-production would be great.
What about the fat clients?
Yes, this would work perfect for fat clients. By the way, there may be soon a better option for Azure for fat clients. Azure just announced Windows 365. We don't have all the details yet, but it's expected to be very similar to AWS's workspaces.
So now that we've covered some of the Azure basics, let's talk about performance considerations on Azure. Frank, what should we be concerned with to give users blazing fast performance on Azure?
Oh, this is deja vu. I talked about this last week. Basically for JDE though, the two main bottlenecks are going to be the speed of the database server and the single core clock speed on your enterprise servers.
On the enterprise servers, can I improve performance just by adding more CPU cores, even if they're running at a slower clock speed?
Not really. I mean, let's think about this a minute. More cores can improve concurrency, but a UBE or a call object thread, those are single processes. So you can separate the batch job into like a load balanced or mobile version data selections. That way you can, the aggregate time is less because you're running more jobs concurrently. But higher clock speed helps your compute intensive processes such as your financials or ERP, the job project costing applications, etc.
So the whole concurrency versus speed thing that you were talking about, would a good way to think about that be like the interstate system? The cores are like the number of traffic lanes, and the clock speed is like the speed at which an individual vehicle travels. More cores or more lanes don't make that vehicle go any faster.
Yes, exactly. I mean, more lanes could help the individual vehicle avoid a traffic jam, though.
Got it. So switching now to the database server, what affects its speed?
And the two main things, it's going to be the amount of RAM and the speed of the storage.
What about the speed of the CPUs on the database server?
It really doesn't matter that much.
So what I want is as much RAM as possible with as few CPU cores as I can get away with.
Yes.
So like in the example of SQL Server we were discussing before, I could get a larger VM, but then constrain those CPUs to limit that licensing liability.
Yes, that's one good strategy.
Dan, Frank mentioned before the speed of the storage on the database servers. What are our options for Azure?
So just like AWS, Azure gives you the options to choose what type of storage you want to use with your VMs. As you can see from this lovely diagram, it ranges from 2 turtles slow all the way up to 3 bunnies fast. This gives you the option with latency coming in from 20 milliseconds all the way down to 1. But one important note to make is that snapshots cannot be made on an Ultra disk. So if you want to use this for a database, you will have to rely on traditional database backups, but this is something that we can definitely architect around.
Yeah, UltraDisks, they're good for like SQL Server TempDB, some of the transaction logs, or in Oracle's case, redo logs, where you really need some extreme I/O. However, for most production databases, that premium SSD works very well, and you really shouldn't need to use Ultra.
Right. Anything needing extremely fast I/O will benefit from the Ultra. On TempDB, though, if you're using a VM with local NVMe and it's big enough to put your TempDB there, you will get the performance without the cost.
Yeah, and that makes sense since TempDB for SQL Server gets recreated every time you restart it. So you really don't have to worry about protecting it.
So Frank mentioned wanting fast clock speeds for the enterprise servers. What does that look like on Azure?
So this actually is some more deja vu from last week. This is a slide where Josh got all excited about the 4.5 gigahertz option on AWS. Although Azure is not quite as fast as although Azure is not as fast as AWS in pure clock speeds, it is definitely on par with the rest of the community coming in at 3.7 gigahertz. Frank, what do you think about that?
Well, again, generally, as long as E1 has servers running 3 gigahertz or higher, it'll perform pretty well.
So shifting our discussion now from performance to resiliency, Dan, what can you tell us about the difference between in-region resiliency and out-of-region disaster recovery? What are the options there and how does that work?
Sure. So the difference between the two is very important to understand. A region is a geographic area, so you can think of a metro area. And then an availability zone is a physical data center that provides infrastructure resources. So think of a data center inside of that metro area. With Azure, you can leverage this to protect services in a region with another availability zone, often very easily. And you don't have to think about snapshots, copies, replication, IP changes, RTO, or really anything else that factors into a typical DR solution. On the other hand, if the customer's availability requirements drive a more geographically diverse architecture, we can use Azure regions to deliver that as well.
Yeah, but it is important to note for optimal JDE performance, though, you want to have everything running in the same availability zone. Even 1 or 2 millisecond latency between AZs is not ideal. E1's very chatty, and that additional latency does add up and it slows JDE down.
But
So does the host, I'm sorry,
yes,
Dan, go ahead.
yeah, no, that was just something I wanted to put. So recovery into another availability zone is pretty fast. You just recover the server from object storage, and most of the volumes are pretty small. And so the exact recovery time is dependent on the size of the volumes. So larger the volume, the more time it would take to recover.
So Dan, that's within or between availability zones within a region. Does the same thing hold true with out-of-region disaster recovery?
It does. However, it's important to note that there's additional architecture, some setup and networking considerations involved with putting it in a different region, but it's very achievable.
So what about databases where I might need a lower RPO?
So the best practice in the JDE community will be running SQL Server on top of an Azure VM and use always-on clustering for HA purposes. As shown in the diagram, if SQL A fails, the database is brought online in SQL B in the other AZ. And then snapshots are replicated across regions in case of a regional disaster.
So would this be similar if we were using an Oracle database?
If you're running Oracle Enterprise Edition, you can use DataGuard and replications between the AZs. For Oracle Standard Edition, though, you'll need to use VM snapshots and/or RMAN backups for recovery.
Right. I remember Josh talking about this last week with AWS and how that it's the only cloud he's aware of where you can do HA as a cloud native option for Oracle Standard Edition. And specifically, that's going between availability zones.
Yep, that's right.
So what if I'm worried about data loss within Azure? I'm doing the snapshots to protect things, but I'm using Standard Edition. What does that look like?
We would just do more snapshots more frequently.
Got it. So that would protect the data that way. So we've been talking a lot about database deployment on Azure and have already gotten into a lot of the details around SQL Server. How does the licensing work when deploying Oracle on Azure?
Yeah, that's a great question. So Frank, as we discussed last week, most JDE customers will have access to Oracle database already because of their JDE license.
Yes, if they have the Oracle Tech Foundation as part of their JDE licensing, they can deploy Oracle Standard Edition 2 without worrying about that licensing too much. Since this is licensed by user, it doesn't matter how many processors you deploy it on. If you have Oracle Tech Foundation, it's a sunk cost. You're already paying for it, and you really should consider using it.
So Dan, how would this work if a customer has Oracle processor-based licensing?
It's not great. For Azure and AWS, for that matter, you can't use the Oracle processor core factor anymore.
What exactly does that mean?
The Oracle processor factor core is from the days when the majority of Oracle databases were deployed on Unix. It was Oracle saying that RISC-based processors on Unix were a lot more powerful than the x86 cores. So it let an individual processor license cover more than one core.
What does this do to the economics?
It means for Azure, you're going to need twice as many licenses to cover the same number of cores. As an example, if a customer needs 16 vCPU on their Oracle database server, then they would need 8 processor licenses to cover it. If deploying on-prem or at OCI, they would only need 4 processor licenses. It's important to remember that there's a lot more nuance related to Oracle licensing than we are covering here today. But we would definitely advise you to consult Oracle directly with your own scenario and then try and get their guidance in writing. But alternatively, we'd of course be happy to help.
Can you give me an idea of the type of dollars we're talking about here?
Sure. Yeah, it gets expensive fast. On Azure, licensing 16 vCPUs will cost $380,000 upfront with $83,000 in annual support. As you can see, this is twice as expensive as running on Oracle's cloud.
So what can we do on Azure to help contain these costs?
Interestingly enough, there might be an option with a strategic partnership Microsoft and Oracle entered 2 years ago. Oracle and Azure have cross-connected their clouds, and according to the documentation, this is certified to run a JD Edwards.
So you can run your database on OCI, optimizing the licensing cost, and then run all the non-database JD Edwards servers on Azure?
Exactly.
Yeah, I'd approach that with a lot of caution. Remember earlier when I was talking about availability zones, I advised not splitting your JD servers between AZs. The reason is JD Edwards, again, is extremely chatty and doesn't perform well with latency. Even a small amount of latency of 1 or 2 milliseconds can adversely affect that JD Edwards performance. Maybe this be okay for a fat client, but keep your web and enterprise server in the same cloud and AZ as your database server. However, there are several other multi-cloud scenarios you could consider, such as JD Edwards E1 in OCI, and then in the various Microsoft cloud servers in Azure, you can have Office 365, Azure Active Directory, or maybe Power BI.
Right. I know in the latest version of the JD Edwards reference architecture, it shows everything running in a single AZ for this very reason.
Right. If you're licensed by processor, OCI is a better way to go. As a matter of fact, we'll have a presentation next week regarding JD on Oracle Cloud Infrastructure.
Thanks, Dan and Frank, for all of this information. In recap, if you're stuck on circa 2008 Windows SQL, or you have an EA or MPSA with Microsoft that allows for savings through hybrid benefit, considering Azure is a must. If you're deploying on Azure, use Oracle Linux whenever possible to keep Frank happy. If you have Oracle processor-based licensing, go with OCI. For the most part, all the core features we've discussed in hyperscale clouds that are important to the JD Edwards community, features like regions, availability zones, snapshots, etc., are all commodities available regardless what hyperscale cloud you're deploying on. Which cloud is right for your organization? What are the trade-offs? What are the non-commodity aspects of those clouds that you could leverage to your advantage? We love the opportunity to help game these options out for you. Please join us next week as we continue our Find Your Cloud series with our exploration of JD Edwards on OCI. We'll be joined by Clayton Seeley from Oracle. Clayton runs the JD Edwards technical task. Technical task force for Oracle and is responsible for the JD Edwards reference architecture, one-click provisioning, and much more. Next week's session will be expanded to 45 minutes to accommodate all the extra content. Email us at findyourcloud at erpsuites.com with any questions or to schedule a free assessment. On behalf of the entire ERP Suites team, thank you for attending.